The next question, number 12. For a specified input voltage and frequency, if the equivalent radius of the core of a transformer is reduced by half, the factor by which the number of turns in the primary should change to maintain the same no-load current is, well, we have our options here, A, B, C, D. 1 by 4, 1 by 2, 2 and 4. Okay. So because the question talks about transformer, let's first write down the voltage equation of a transformer. Please recall, for a transformer, we know that the voltage, let's write down the primary voltage. V1 can be written as root 2 pi F phi m times n. Now here the flux phi m can be written in terms of area as well, right? So V1 can be written as root 2 pi F Bm times A times n. Now in order to maintain the same no-load current, the flux in the core should be constant. That's a very important point. So the flux here must remain constant. So V1 by F must be constant. So if V1 by F is constant, what does that tell us? That implies that root 2 pi Bm is also constant. This is because the flux in the core must remain constant. And this is also because in order to maintain the same no-load current. Okay? So the next step is to analyze the area here of the core. Because the question says the equivalent radius of the core of a transformer is reduced by half. So first let's write down what the area of the core would give us. Now the area A, okay, so the area A can be written as 2 pi RL. Here R is the radius and L is the length of the core. So according to what we have already seen now, in order to maintain the same no-load current, we saw that most part of the equation, the voltage equation must be constant. So that implies that the radius times n should also be constant. The number of turns, right? It should be constant. So the question tells us that the radius is reduced by half. You see there? The radius of the core of the transformer is reduced by half. So what happens when the radius is reduced by half? We will have to write down the ratio. So it is given that, let's call this R2. Okay? R2 is equal to R1 by 2. That's what's given to us so far. This is the radius, initial radius, which is reduced by 2 by half, which is reduced by half, and the new radius R2 becomes R1 by R2. And this is because the new area is reduced by half as well. Now using this expression here, R, the radius times the number of turns is constant. So using this we can write down the proportion. R1 by R2 is equal to N2 by N1. This is the expression we get. R1 times N1 equals R2 times N2. So this is the ratio that we can write down for radius and number of turns. So from this, we have our initial value of the radius. We also know that the initial number of turns is n. So if radius is reduced by half, what happens to the number of turns? Let's see now. We'll have to write it in terms of N2. Okay? N2 is equal to R1 by R2 into N1. Now what is R2? R2 is R1 by 2. Let's substitute that over here. What do we get? You will end up with 2n1. So this means that if the radius of the core of the transformer is reduced by half, then the number of turns is increased, it is doubled. So in order to maintain the same no load current, the number of turns required is twice that of the initial value. That is the mean.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.